It is that time of the Math HO where you finally learn something else other than the real number system. And we get to look at something called imaginary numbers. Now, what are imaginary numbers? They are square root of -1. Before, when we are dealt with the real number system, when there was a negative number inside of a square root, we were very scared of it, and we just said, nope, we're not going to work with that. So if we had a square root of -3, more often, we were just like, nope, that does not make sense, and it is not possible. Now it's different. Complex numbers actually deals with the square root of negative numbers, and we call this an imaginary number because it is simply just not real. It's something we have to imagine that exists for us to solve different types of things in math. And we define it as I equals the square root of -1. Now, let's try this problem, this quadratic equation. We see that z squared minus 3z plus 5 equals to 0, and we're trying to find the solutions of z. Now, if we use the quadratic formula, this is what we get. And we see that we get -11 over 2. And before, if this was a quadratic function, where z was equal to x, we would say, there's going to be no solutions. Now it's different. Square root of negative numbers does exist, and we put it into the form of this imaginary number. So this becomes 3 plus square root 11i over 2, where I is equal to the square root of -1. And this is the solution. And yeah, it's going to be the first time where you see a different type of number in your life, and it's going to confuse you a little bit, but once you deal with it enough, it makes sense. It's something that it's not going to be that hard to deal with. Now, on the top here, we're going to go through some basic properties about complex numbers. First one is that z, a complex number, is going to be equal to a real number, plus b, a real number, times I, the imaginary number. And this is the form it always is going to be in. So this is going to be the z bar, and that is going to be the conjugate pair of z, where simply the plus and minus just switches. So it's going to be a minus bi. Now, if we look at the middle here, I squared is going to be equal to -1, as you might expect. And very important notation is this. Re bracket z refers to the real part of this complex number, if z equals to a plus bi. And as you can see, the real part is going to be a, and this imaginary part, noted as im bracket z bracket, this is going to be representing the real number in front of the imaginary number. So this is the notation that we are going to deal with. And throughout this chapter, you're going to be seeing a lot of cool things about complex numbers, and you're going to be solving different types of complex number problems, and they're going to be quite interesting. So I hope you're pretty excited for that.